So the name of the project is a comparative study of simulators for sim-to-real deep reinforcement learning. The aim of the project is to compare the accuracy of two physics-based simulators named MuJoCo and Pybullet for a sim-to-real deep reinforcement learning task. A UR10 robot will be designed in these simulators, and then a policy will be trained for each simulator using the DQN algorithm. So the first, the environment and the task was designed for these simulators. So there's a goal position in the environment, and the object of the robot is to reach this goal position as fast as possible. And in every step, robot receives the rewards from the environment, the goal position of the environment, and the gripper position, the position of itself, basically. So the reward function was designed like this. So the gripper position and the goal position, the distance between gripper position and the goal position is multiplied with -1 and this is given to the robot as a reward. So the DQN was used to train these policies, and the DQN with one hidden layer and two hidden layers was used. As we can see, after training for 4,000 episodes, all these models reach to converge to a reward around -2. So for the testing, a real UR10 robot was used, and this is the testing environment. So basically, in this case, we have 4 goal positions now, and robot has to traverse each one of them to complete the episode as fast as possible. So it first goes to the first goal position, then the second one, then the third one, then the fourth one. And we record the time it takes to complete the episode, the total number of steps it takes during the episode, and the total reward it receives within the episode for testing in the real UR10 robot. So when transforming to the real environment, one of the challenges faced was the noise. So in the simulators, there is no noise. So when you perform an action, there is no. So in the simulators, when you perform an action, the expected position is fixed. But in the real UR10 robot, when we receive the gripper position from the sensors of the robot, and that is noisy. So when we perform an action, we could end up in a slightly different position than expected. Environment configuration must change also. So we must make sure that all the goal positions generated should be reachable by the UR10 robot safely. So we had to redesign the task space limits for the environment, and the simulators were also redesigned, and the models were retrained by these new task space limits. So after testing, we see that this is the results. We see that if we look at the standard deviation, there's a standard deviation in the results, which also comes from the noise as expected, because we end up in a slightly different position when we perform an action in simulators. That is not our case. In this environment, we can also see that DQN with adding an additional hidden layer to the DQ network actually does not result in better results. Maybe adding more than one hidden layer, maybe several hidden layers, could also be tried to see if that changes anything. And also we can see that actually models, policies trained in Pybullet performs better than MuJoCo. If you look at the rewards, for example, we see that it gets higher rewards, and it completes the episode in lesser time. It takes lesser steps to complete. So for future work, we could try to design a new environment, maybe a more complex task, and repeat the experiment again. Also, we could use more algorithms instead of deep Q learning. We could use proximal policy optimization, for example. So this is the gist of the project.